So based on our discussion up to this point, we have a way of finding entropies from experimental measurements of heat capacities, but we need a baseline for entropy. And the third law establishes that baseline. And I'll just go and write out what the third law is. It's related to what is entropy at 0 Kelvin. Yeah, absolute zero. So the third law states that the entropy is equal to 0 at 0 Kelvin for a perfectly ordered crystal and entropy cannot go lower. So there is no such thing as a negative entropy. 0 is the lowest possible you can get, and that happens at absolute 0 for a perfectly crystalline substance. And the third law makes a lot of sense if we consider Boltzmann's equation, the statistical view of entropy, right, where we're thinking about how many different microstates correspond to a certain macrostate. If we have a perfectly ordered crystal, all the molecules we have are in their lowest possible state. If we draw out a bunch of energy levels at 0 Kelvin, everything is going to be in its ground state, perfectly ordered, etc., etc. And we can think about this in terms of the electronic energy or other types of energy like vibrations, rotations, even translation. They'll all be in their lowest possible state. And we know that if everything's all in one state, W equals 1, there's only one possible way to have all the molecules in the same energy level, and that will make S equal to 0. We'll give it the units, joules per Kelvin. That's the units it has. So that gives us a baseline for entropy. That's the lowest possible value we can get. What this enables us to do is that using our relationship, right, that delta S can be found by integrating from T1 to T2 the heat capacity divided by temperature of a substance. If we set T1 not just to an arbitrary value, but set that equal to 0 Kelvin, then our S at T2 will be subtracted by 0. By definition, according to the third law of thermodynamics, entropy has a value of 0 at 0 Kelvin, at absolute 0. That means that there is such a thing as an absolute entropy. Unlike things like enthalpy and internal energy, and we'll get to Gibbs free energy that you're probably already familiar with anyway, these are all defined relative, in relative terms. So when we talked about enthalpies of formation, we had to state that the 0 values for enthalpies of formation are for the formation of elemental substances. And that is just set by convention. There's no physical law behind it. With entropy, that's not the case. There is such a thing that is absolutely defined as 0 entropy. And so we can compare everything else to that value at absolute 0. And so these are things that we can tabulate, these absolute entropies. This is something you can then look up in a table, and it's a very powerful, useful piece of information that you can have about a substance. So to be able to get those absolute entropies, of course, we have to do this integration, right? We have to be able to integrate the heat capacity at constant pressure as a function of temperature. And that allows us to find these absolute entropies. So in the next video, we'll take a closer look at maybe how you would actually do that, what the experiment might look like, and some other things you have to think about along the way.